Hi, I have done this video to explain some basics and more advanced information about thermal reaction norm of sex ratio. I receive regularly some demand of information about how to estimate the thermal reaction norm of sex ratio, how to use this kind of thermal reaction norm, and then I will answer the basics in this video, and always you can contact me to have more information. The TSD, temperature-dependent sex determination, is a special pattern of sex determination in which the sexual phenotype is dependent on environmental conditions of egg incubation. This is observed in different reptiles, and in turtles the most common pattern of TSD is males at low temperature. You see at the top testes, which is a male gonad, and female at high temperatures. You see at the bottom of the graph an ovary gonad, which is a female gonad. This kind of pattern, low temperature males and high temperature females, is often characterized by two values after the work of Claude Piot and Nicolas Mrozowski: the pivotal temperature, being the theoretical temperature that produce both sexes in equal proportion, and the transitional range of temperature, being the range of temperatures in which both sexes can be produced. If the pattern of sex ratio according to constant incubation temperature is represented by a sigmoid equation, we will see in more details this part just after. The exact value of the TRT depends on the asymptote of here that never reach, from a mathematical point of view, the value of 0 and 1, because it is asymptote. It tends to 0 and 1, but it never reach 0 and 1. Consequently, the TRT defined by the range of temperatures that produce a theoretical sex ratio different from 0 and 1 is infinite. To solve this definition problem, we can define the TRT being the range of temperature in which the sex ratio is between a value n and 1 minus L. I defined in a paper in 1999, L being 0.05, but you can choose other value. It depends simply about your choice, but you must be consistent within your study. The pivotal and TRT values are observed values based on a sample of the population, and then they must be associated with uncertainty measured by standard error. Note that this is uncertainty. This is not an error by itself. The graph linking constant incubation temperature and sex ratio is often named a reaction norm of sex ratio. But it is not a true reaction norm. The definition of reaction norm by Lewinson involved a single genotype expressed at different environments that produce different phenotypes. Here, each egg has a different genotype because of the meiosis in the female and the meiosis also in the male. So it is not a true reaction norm, but an extension of reaction norm at the scale of all the genotypes of the population. The shape of this thermal reaction norm is modeled by a sigmoid curve. Many different equations can be used to represent a sigmoid shape. This curve differs by several characteristics, and the most important of this characteristic is the symmetry around pivotal temperature. Celsius measurement that we use to measure the temperature follows a relative and not an absolute scale. Therefore, an object at 20 degrees Celsius does not have twice the energy as when it is at 10 degrees Celsius. Thus, degrees Celsius is a useful interval measurement, but does not possess the characteristic of ratio measures like weight or distance. Consequently, there is no reason to force the P to be at the center of the TRT in a symmetrical pattern. We discussed this point in a paper published last year in Animals. Then, all the equations that impose a particular shape, symmetrical but also asymmetrical, must not be used. Thus, logistic or Hill model must not be used. There are two constraints to safely represent the thermal reaction norm of sex ratio. A model with asymmetry controlled by parameter value must be used. Several equations have been proposed in literature: allogistic, Hulin, flexit star models with more or less flexibility. I present here a new version of the flexit star model. This model has the advantage to have all the three parameters P, SH, and SL being all in unit of degrees Celsius, and the TRT is simply the sum of SL and SH. This model is named Flexit Double Star and is available in Abreu-Grobois Air package that you can find in CRAN. We will see now how to fit the parameters of the model, that is the sigmoid shape, can be obtained using observations. The observations are temperature, constant incubation temperature. At this temperature, Ti, a total of Si embryos are sexed, and among them, Mi are males, Fi are females, and then Si is the sum of Mi and Fi. The likelihood of this observation in the model SR, which is dependent on the temperature, Ti, the values of parameters P, SL, SH, is obtained by the application of a binomial distribution, and then we estimate the likelihood of Ti, Mi, Fi, knowing the expected sex ratio, which is dependent on Ti, P, SL, SH. Note that when you are written this, you are doing hypothesis. The identification of males and females must be correct. But we know that it can be wrong because misidentification of sexual phenotype can occur. This misidentification can be author dependent and is not independent also on the incubation temperature T. Indeed, it is often complicated to identify the sexual phenotype when T is close to P, pivotal temperature, because of the presence of ovotestis gonads. Then you can expect to have a publication or author effect. We suppose also that the likelihood, which is a conditional probability, of Mi and Phi in SR follows a binomial distribution. But it can be wrong if there is a genetic component in sex determination. In this case, you will have more 0 or 1 sex ratio, all males or all females, than expected. Then you can expect to have a clutch or female effect. You have two main statistical methodologies to fit the model to your data: maximum likelihood or Bayesian statistics. Never use the least square statistic for sex ratio. This is wrong. The use of maximum likelihood or Bayesian statistic is not just a matter of personal choice or to be à la mode because Bayesian statistics is supposed to be more complicated. The maximum likelihood is based on searching for the model maximizing the likelihood of data knowing the model. The model selection based on IC also use the likelihood of data knowing the model. The problem is that we don't know the model. And then the use of data knowing the model is misleading. We know the data and we search for the model. Then we should use the likelihood of the model knowing the data. Bayesian statistics offer this latter perspective, likelihood of model knowing the data. If you want to do some model selection, in Bayesian world, you should use WIC, Watanabe-Akaike Information Criterion. In conclusion, to estimate the population equivalent of the thermal reaction norm for sex ratio, you should use the Flexit double star model fitted using Bayesian model. This model must use only data obtained at constant incubation temperature. It is very important to remember that this pattern must not be used to estimate sex ratio from field. Even if you estimate the average temperature in your nest, you must not use this thermal reaction norm. It works only for constant incubation temperatures. We will see in another video how to estimate the sex ratio from field using fluctuating temperature. Of course, if you have any question, you can contact me. Thanks. Bye.